right, guys, so we're going to go on and get started.
Yes, sir.
We're going to go on and get started with the lesson today. So we're talking about properties of logarithms, And we have three main properties that we're going to look at today, or part of this here. Product property, quotient, and power. Product property says if we have two or more things multiplied together inside a log, we can rewrite it as a sum of those logs. Quotient property says if we have two things being divided inside the log, we can rewrite it as subtraction. And power property says if we have an exponent inside that logarithm, we can take that exponent and throw it to the front. So what we're going to do with these here is take a logarithm, the natural log of 5x to the 7th over y, and expand it out as far as we can possibly expand it using these properties. Now, the first property we're going to use is quotient, our division property. First property we're going to use is quotient. So we're going to have the numerator first and the denominator second. So when we use this property, we'd have natural log 5x to the 7th minus the natural log of the denominator. So we have the natural log of 5x to the 7th minus the natural log of y. Probably going to have to run copies because I think some six five. Why is it doing that? Okay. Should be in room 10. Mm-hmm. 3. All right, guys. So, quotients first. Second, once we finish doing the quotient, our second one is product, our multiplication property. Now, looking at this here, the second one, the natural log of y, does not have a product. We don't have two or more things being multiplied together. So we don't apply it to that one. But our second, or our first one, the natural log of 5x to the 7th, can be rewritten as the natural log of 5 plus the natural log of x to the 7th minus the natural log of y. And realistically, we can put parentheses around both of those because we're just replacing the natural log of 5x to the 7th with the natural log of 5 plus the natural log of x to the 7th. But because there is no sign or number in front of the natural log of 5x to the 7th, we will end up just dropping those parentheses anyways. And the last property is our power property. And the only spot we have it is with this x to the 7th. So our power property says we can take that exponent and move it to the front. So what we have is we still have the natural log of 5 plus 7 times the natural log of x minus the natural log of y. And that's it. That is it in fully expanded form. Each term inside the parentheses, we have exactly 1. They cannot reduce. They don't simplify. We are finished. So for expanding, we go quotient, product, power. Quotient, product, power. Questions on this here? You can? Yeah. You're good. It did what I thought it was going to do. It legitimately printed this one page. There you go. All right, let's look at problem number 2. I can get it in a bit. So we want to expand the natural log of 3x to the 5th over y. So again, focus up here, guys. Focus up. We do the quotient product first, quotient property first. So we'd have the natural log of the numerator, 3x to the 5th, minus the natural log of the denominator, which would be the natural log of y. Quotient property says we can take the natural log of the top and subtract from it the natural log of the denominator at the bottom. Questions on this here? Then we move on to property 2, and we see if there's products in either one of these here. Since the first one, our 3x to the 5th, has a product of 3 and x to the 5th, we can write it as a sum. The natural log of 3 plus the natural log of x to the 5th. And it's still being subtracted from the natural log of y. Questions on this here so far? Now, since there is no sign in front of that natural log of 3x to the 5th, we don't need parentheses around it. They would just drop. Now, the only thing we have left is our power property, and because of that x to the 5th, we need to take that 5th power and move it to the front, telling us that the fully expanded version of this here is the natural log of 3 plus 5 times the natural log of x minus the natural log of y. If the log, especially we get a number like log base 3 of 3, based on what's inside simplifies, we'll simplify it. If not, we can leave it as is. Because the natural log of 3 is not a nice number, it does not reduce nicely, we're going to leave it. Unless it tells us to approximate, I'm going to leave it in logarithmic form. Questions on this here? Next one we have is log base 6 of 3x to the 4th. Our first property, we look at quotient. Is there something being divided here? Well, no, there is no division in this, so we don't do quotient because there is no division. But we do have two things being multiplied together. So our product property says I can rewrite this as a sum of those terms. Now, it doesn't have to be just 2. We could have 3 things being multiplied together, and we would write it as 3 separate logs being added together. Questions on this so far? So that finishes the power or product property. Now we can move on to our power property. And our power property says we can take the exponent and move it to the front. So log base 6 of 3 plus 4 times log base 6 of x. One term in each one of them, no exponents. So that is it. Questions on these here? We ready for the next one? Natural log of 5 over 12x. So we do have a quotient. We do have 2 things being divided. So according to the quotient property, It'd be a natural log of the top minus the natural log of the bottom. So it'd be natural log of 5 minus the natural log of 12x. Questions on this here? Now we do have a product in one of them, yes? Because the second one, the 12 and the x, are being multiplied together. So according to the product property, I can rewrite this as the natural log of 12 plus the natural log of x. But this natural log has the minus in front of it to start with, yes? So this one here, we do need those parentheses around it, because that negative is being applied to not only the natural log of 12x, but it has to be applied to the natural log of x. If a term, so 12 and x are both, since they're both in the bottom of that fraction, when it's fully expanded, we know that they're both going to have a minus sign in front of it. Both going to have a minus sign in front of it, because both of them are going to be in the bottom of the fraction. Questions on this here? We feel good with this so far. Well, now we're going to condense. We're going to go in the opposite direction. We're going to put it back together. Because depending on the expression, sometimes having it written out in expanded form works better or nicer. Sometimes being able to condense it is going to be more efficient. And to put it back together, the first property we're going to use is the power property. Take negatives. So if there's a negative, if there's a minus sign, we want to take it into the power also. Because seeing this and working through this and finding a very efficient way to do this, taking those negatives into the exponent makes this nicer to work with. Not always. There's a 3% time, there's a certain setup that's going to work nicer if we don't do this. It just means less steps. Because if we look at this first one, powers, we're looking for the number in front of the log. The only thing in front of log of 9 is positive 1, so it's just going to stay log of 9. There is no power property we're going to apply to it. But the middle term, 3 log of 2, according to the power property, we can take that number in front and move it back up into the exponent, giving us plus log of 2 to the third power. Now the negatives, because the next one we have is minus 3, minus log of 3. And normally we wouldn't take the negative up. Most would say don't worry about that. We're not worried about the negative. I want to take the negative up into that exponent, because we will still have log of 3. But because we took that negative into the exponent, it's going to change it from minus to plus. And that exponent will be negative what? 1. So we're really taking that negative 1 in front of log of 3 and moving it up into the exponent. And this is nice because now the only sign between the logs is plus. Product property says that if we have 2 or more logs being added together, we can rewrite it as a single log with what's inside being multiplied. Our quotient property, sort of putting it back together, says if we have 2 things being subtracted, we can rewrite it as a single log with what's inside being divided. Do I have subtraction anymore? No. We've removed quotient property from condensing. We don't have to worry about the quotient, when to do product or quotient, in what order, how do I set. It removes it completely. Because that's one of the most tricky parts of condensing, is knowing when to do product and quotient. But if I take that power, that negative power, up into the exponent, that subtraction up there, I remove quotient from the equation. Now the only other step is product and then fixing our exponents. because I do have 3 logs being added together, I can rewrite it as a single log with what's inside each of them being multiplied. So log of 9 plus log of 2 to the third plus log of 3 to the negative 1, we can rewrite it as log of 9 times 2 to the third times 3 to the negative 1. Questions on this here? Now, the only thing we have to really do besides simplifying this here is we do need to fix that exponent. And the only way to turn an exponent from positive to negative or negative to positive is to move it from the top of the fraction to the bottom or from the bottom to the top. So that 3 is going to go to the bottom of the fraction, and it's going to become 3 to the first, or just 3. Questions on this here? Now, one nice thing about this, because we're almost finished simplifying, is that inside that logarithm, we have 9 times 2 to the third over 3, yes? Is there a variable in that spot? No, it's all numbers, yes? We like that because I can come over to the calculator and say, hey, what is 9 times 2 to the third over 3? 24. 2 to the third is 8. 9 over 3 is 3. 8 times 3 is 24. Log of 24 does not reduce nicely or reduce to a nice integer number. So we're just leave it as log of 24. Question on this here. Be ready for the next one. Log of 6 plus 4 log of 3 minus log of 3. So our power property is going to have no impact on log of 6. There is no number in front of it. There's nothing we can take up into the exponent because I'm not taking positive 1. We can, not going to do anything. The middle one, we're wanting to move that 4 back up into the exponent. So that's telling me I go from 4 log of 3 to log of 3 to the 4th. And lastly, we're going to take that negative up into the log. And it's going to turn it from minus log of 3 to plus log of 3 to the negative 1. Questions on this here? Question on anything we've done so far? So we have 3 logs being added together. So we can rewrite it as a single log with what's inside being multiplied. And at this point here, I would make any of the negative exponents positive by moving them from the top of the fraction to the bottom, or bottom of the fraction to the top. Most likely it's just going to be moving them back on bottom. Which for us here would say that we have log of 6 times 3 to the 4th over 3. Now, realistically, at this point, we could have actually just typed in 6 times 3 to the 4 times 3 to the negative 1 into the calculator. They're just numbers. It'll do that just fine. If it was variables, instead of 3 to the negative 1, it was x to the negative 1. We have these variables to the negative power. We do have to actually just move them ourselves. So it tells us it's log of 162. Questions on this here? We ready for the next one? Log of x minus log of 9. We're going to see this in 2 ways. Because the way we've been doing this, the first thing we want to do is move that negative up into the exponent. Telling us I have log of x plus log of 9 to that negative first power. Now, none of the ones we've had up to this point have had a number in front of that minus, because if it said minus 2 log of 9, it would become plus log of 9 to the negative second. We take the number and the sign with it. Questions on this so far? We have two things being added together. So according to the product property, I can rewrite this as a single log with what's inside being multiplied. And yes, I could have, if I wanted to, have rewritten this as log of negative 9, or sorry, not negative 9, log of 9 to the negative first times x. Product property doesn't matter. But because we do have that negative exponent, we do have to move that 9 from the top of the fraction to the bottom, telling us that we have log of x over 9. Questions on this here? I did say earlier that this method works well 97-ish, 95% of the time. There's a select few where it doesn't work as well. It adds more steps. This is one of them. What was our quotient property? Quotient property says if I have two logs with the same base being subtracted, I can rewrite it as a single log with what's inside being divided. Isn't that the quotient property right there? So according to the quotient property, this should be log. First log is going to go on top, second log is going to go on bottom, x over 9. So this one here, because we only had two expressions being subtracted, no exponents, nothing else, it's easier to just use the quotient property and go straight to the answer. However, if we were trying to condense this one back, pulling those negatives up into the exponent is going to make this nicer. Because for us to do this one, we would have to, by the process, we'd have to factor that negative out of both terms. Then do product of the second two, then do our quotient. So it's a lot more steps than just pulling those negatives up. Questions on any of this here? I know we're moving at a decent pace, but I think we're getting this here. It's just taking that property and applying it. Because if we look at this last one, natural log of 4 plus 3 natural log of 3 minus the natural log of 12. Natural log of 4 is not going to change. But our 3 natural log of 3, we're going to move that 3 from in front of the natural log back up into the exponent. Power property. And then I'm going to move that negative also back up into the exponent, giving us the natural log of 12 to the negative first. Now, since we do have a product, or 3 logs being added together, I can rewrite this as a single logarithm with what's inside being multiplied together. Now we do want to resolve that 12 to the negative 1, make that negative 1 power positive, so we have to move it from the top of the fraction to the bottom. Yes? Now we got to figure out what 4 times 3 to the third divided by 12 is. Yes? Be a little bit smaller. So does it matter how we multiply 2 or more things together? No, 3 to the third just says I'm multiplying 3 by itself 3 times. Yes? I'm going to take one of those 3's and multiply it with 4. What's 4 times 3? 12. What is it over? So that 12 and the other 12 will simplify out, yes? So we only have 2 3's left on top. 3 times 3 is? Don't have to do that. Calculator will also tell us it's 9. Questions on this here? Yes. Now, part of the reason that they did this and that we have this and that these work is back when calculators, neither one of them could actually calculate logarithms at all. So we had tables to do this, and printing tables for every log of every base, one, is not realistic or productive. It's just that's too much information to try to carry around. So if I had log base 2, I knew what its values were. We could actually use these properties to figure out what the logs are. So if I wanted to find out what log base 2 of 3/7 is, and I know that log base 2 of 3 is 1.585, and I know that log base 2 of 7 is 2.807, we can use our quotient property to say that log base 2 of 3/7 is the same as log base 2 of 3 minus log base 2 of 7. And it already told us that log base 2 of 3 is 1.585. We also know that log base 2 of 7, it told us, is 2.807. So I was able to rewrite it in terms of logs that we actually know the value to. We can replace them with their value. And now we just need to subtract 1.585 from 2.807. Which is negative 1.222. Questions on this here? Is the exact same thing. Because again, this gives us a way to be able to calculate these, evaluate these without actually knowing or having to calculate it itself. Questions on this here, guys? Log base 2 of 21. Using 3 and 7 with product, quotient, or power, how can I rewrite 21 using 3 and 7 to get there? Well, 21 is what? 3 times 7. And according to our product property, we can rewrite it as log base 2 of 3 plus log base 2 of 7. And log base 2 of 3 is still 1.585. And log base 2 of 7 is 2.807. Now we just need to add them together. .392. Questions on this here? Or we can do log base in the graphing calculator and get to the number already. Using product, quotients, or power, how can we get to 49 with 3 and 7? 7 times 7, or 7 squared. We don't even need 3 for this one. Power property says we can move the exponent to the front, telling us that we have 2 times log base 2 of 7. Well, we know log base 2 of 7 is 2.807, so we're multiplying it by 2. 4 carry the 1, 6 carry the 1. I believe we should get 5.614. Questions on these here? Question anything we've done so far? Log base 3 of 4/5. Well, this is kind of nice. It's already written the quotient out for us. Because we can say log base 3 of 4 minus log base 3 of 5. And it tells us log base 3 of 4 is 1.262 minus 1.465. So it gives us a way to use what they told us the approximate values are to subtract them. 262, 465. Is negative 0.203. Log base 3 of 20 would be log base 3 of 4 times 5, which would be log base 3 of 4 plus log base 3 of 5. Log base 3 of 4 is still 1.262. Log base 3 of 5 is still 1.465. So now all we need to do is add those two together. 7, 2, carry the 1, 4, 5, 6. And we should get 2.727. Or the other way we can do it is what? Grab the graphing calculator, do log base 3 of 20, and it'll tell us that it's 2.726, I think 7. It's going to round up. Questions on this here? Questions on any of those so far? Last one, log base 3 of 25. Well, we could say that this is log base 3 of 5 squared. And we can move that 2 to the front, saying 2 times log base 3 of 5. No, it's going to be bigger than that. Oh. Yeah. Yeah. 3, 9, 27. Yeah. That's right. Questions on this here? Realistically, we could have typed those into the graphing calculator, been done, yes? Well, the last thing we're going to look at is actually going to be really nice. Because the reason we couldn't type these into the yellow calculator, our 30xs, is because it cannot do log base. But we have a formula called the change of base. The change of base formula says I can change the base of the logarithm to whatever I want it to be. There's two that we're going to either use, most likely. 10 or E. Because if it's log base 10, that means that LOG button on every calculator will work. E says I can use natural log. And we can change it to these bases. So if we look at the first one, log base 3 of 8, I can rewrite this as log of the numerator 8 over log of the base, which is 3. So log base 3 of 8 is equivalent to log of 8 over log of 3, which will actually have the same value as the natural log of 8 over the natural log of 3. I grab the graphing calculator, go math, log base 3 of 8, and it tells me it's this here. Alpha y equals enter. Log of 8 over log of 3 is that exact same value. Interestingly enough, natural log of 8 over the natural log of 3 is still 1.893 if we round to 3 decimal places. So that means I don't actually have to use the graphing calculator to do log base. We can actually use the 30xs and get to it a little bit quicker. Questions on this here? So if I wanted to evaluate or rewrite log base 7 of 11 in terms of logs and natural logs, we'd have log of what? 11 over log of 7. Which is equivalent to the natural log of 11 over the natural log of 7, which is approximately going to be 1.2, 1.1, 1.232. Questions on this here? We're ready to look at the next ones. Evaluate log base 6 of 24. So if we wrote it in terms of logs, log on top, log on bottom, this would be what? Log of what? 4 over log of 6, which is the same as the natural log of 24 over the natural log of 6. Now, logarithms, really what that's saying when we're finding a log is 6 to what power is 24? Well, we know there's not one, at least not an integer, because 6 to the first power is 6. 6 squared, 6 times 6 is what? 36. So we should know whatever this value is should be between 1 and 2, yes? Is 24 closer to 36 or 6? 36. So we should expect this result to be closer to 2 than it is to 1. Can we say log of 24, I think it was 24, or was it 26? 24 over log of 6, 1.774. So it is closer to 2 than it is to 1, because it's closer to 36 than it is to 6. Questions on that one there? Evaluate log base 2 of 19. Well, this is the same as log of 19 over log of 2. It is the same as the natural log of 19 over the natural log of 2. 2 to the first is 2. 2 squared is 4. 2 cubed would be 8. 2 to the fourth is 16. 2 to the fifth is 32. So by the reasoning on the last one and this one, well, this should be 4, because 2 to the fourth is 16. So it's got to be at least 4. We're going to see how much more. It's not 16. 19. I was about to say if it's 16, that would work out very nicely. It'd just be 4. 4.248. And that's it. Questions on this here? We ready for the next thing?